So hi children, in the previous video we discussed up to 5 problems now. Now here in this video we are starting from 6th onwards. So what is that 6th question? If A is a perfect square, then the digit that should not be there in its units place. So what they are saying, here A is a perfect square, but here the condition what they are saying, the digit which should not be there in its units place digit. So what is that first property that is related to first property of perfect numbers only, no, perfect squares. What is the first one? A perfect square should not ends with 2, 3, 7, 8. Okay, so here 2, 3, 7, 8. 2, 3, 7, 8. So just to say that options, here 5, here not there, so 5 is there, 9 is also there, and 6 will be there. So which number is not there? That is D only, no, which means 3 is not there, no. Okay, if that in that number in a perfect square 3 is there, then what will happen? We can say that that is not a perfect square. Why? Because if that is a perfect square, it should not ends with 3. It should not ends with 3, and in the same way it should not ends with 2. It should not ends with 7, or it should not ends with 8. Okay, is it clear? Okay, now here which option is correct? That is option D, that is 3. Okay, let us see that next one. If a number has one digit, then the number of digits in its square. If a number has only one digit, which means one square, one digit only there, its square is having one digit. 2 square, that is 4. 3 square, 9. 4 square, 16. 5 square, 25, and so on. So what they are asking here, if a number has one digit, if a number has one digit means the squares of that single digit numbers, squares of that single digit numbers up to 9 square. Okay, 10 is 2 digit number now, so up to 9 square. Here in its square, that is having how many digits? So some of the numbers having 1 plus digit, only 1 digit, and remaining are having that 2 digits. So what we can say here? Some of the numbers are having 1, some of the numbers are having 2 digits. So it having that 1 or 2 digits in its square of a single digit number squares, 1 digit number squares. Okay, is it clear? So the next one. Here 64k is a perfect square, then the value of k. Here they are saying that 64k means, here this meaning is 64 into k. Okay, 64 into k. The meaning of this one is 64 into k. Okay, now by which number we have to multiply with 64, we will get it as a perfect square. We will get it as a perfect square. So by options only we have to go. So 64 into 3. 3 4s 12, 3 6 are 18 plus 1, 19. So here we are getting 192. Okay, next 64 is multiple with 6. 6 4s 24. 6 6 36 plus 2 is equals to 38. Okay, next one. So here we will get this one as 384. Okay, next one. Here 9. We have to multiply with 9. So what is that? 64 into 9. 9 4s 36. Next 9 6 54 plus 3 is equals to 57. 576. 576. Next 64 multiple with 2. 2 4s 8, 2 6 12. So here we are getting 128. So here by seeing only we can say that here this number is ending with 2. Square is ending with 2. That's why this is not a perfect square. Okay, next come to this one. Here also this number ending with 8. So we can say that this is also not a perfect square. That is also not a perfect square. Okay, so 2 options completed. Next we have to check for that these 2 options. Now say that 384. 384, its nearest square values already we know that. What is that? 18 18s 324. 18 18s 324, 19 19s 361, 20 20s 400. Just here you have to check this range only. Why? Because this is 384. No, 384. Here how to find that method, that one will come in that square roots concept. No, so there we will discuss that how to find if that is given number is a perfect square or not by using division method. Okay, by using that prime factorization method. We will see that one later in that next worksheet. Now here just to check that here this number is lies in between 361 and 400. So the numbers which lies in between any two consecutive squares, those all numbers are non-squares. Those all numbers are non-square numbers. So we can say that this is also not a perfect square. So which is a perfect square now? 576. 576 is a perfect square of 24. Perfect square of 24. 24 whole square value is equals to 576. So which option is correct? Yes, option C is correct here. Okay. Next. The true statement in the following is, the true statement in the following is, the number of digits in a perfect square is always even. Okay, what is that first point? The number of digits in a perfect square is always even, they are saying. I'll tell you here, 64 is a perfect square or not? 64 is a perfect square. Okay, good. So this is having how many digits? 2 digits. So even number of digits or odd number of digits? Even number of digits only, no? Okay, satisfying. But what about that 225? 225, that is also a perfect square only, no? This number is having how many digits? 3 digits there. Here this is having 2 digits, which means that this is even number of digits. This is odd number of digits. Here we are getting even number of digits. Here we are getting odd number of digits. 2500. This is also a perfect square. So this is having 4. 4 means even number of digits. Okay, but what about the first one point? The number of digits in a perfect square is always even, they are saying. Is always even, they are saying. But we are getting here odd. Okay, here we are getting odd number of digits also, no? Odd number of places also. Okay, that's why the first one is wrong. Next, the sum of two perfect squares is always a perfect square. Is it true? Here I am going to take that 4 and 9. 4 is a perfect square and 9 is also a perfect square. If you add these two, I am getting here 13. So 13 is a perfect square here. 4 is a perfect square, 9 is also a perfect square. If you add these two perfect squares, here I am getting that 13. So 13 is a perfect square. That is not a perfect square, but here they are saying always a perfect square. Maybe sometimes we may get that perfect square, but here in that question what they given in that sentence, always we will get a perfect square, but here we are not getting a perfect square. Okay, so that's why this is also wrong option. Okay, next one, the difference of any two perfect squares. Take the same example here. The difference they are asking. So 9 minus 4 is equals to 5. Is 5 a perfect square? 5 is not a perfect square. So but here again they are saying that always a perfect square. So that's why this is also wrong. Next, the product of two perfect squares is always a perfect square. This one we have to see. So here 9 and 4 I taken, no? So 9 4s 36. 9 is a perfect square, 4 is a perfect square, 36 is also a perfect square. So in all cases it is possible or not, just say that. So 5 5 is 25 and here 4 I am going to take. 25 is a perfect square, 4 is also a perfect square. Its product is equals to 100. Again 100 is also a perfect square. Okay, let us take that one more example. So that is 6 into 6 is equals to 36 into 3 3 is 9. 9 6 is 54, 9 3 is 27, 27 plus 5 is equals to 324. So 324 is a perfect square or not? Yes, 324 is a perfect square, that is the square of 18. 18 square is equals to 324. Okay, so what we can conclude here, the product of any two perfect squares is always a perfect square. So which option is true here? Which statement is true? Yes, that is fourth option, which means option D is that a true statement. Is it clear? Okay,